Hello everyone. In this presentation, we are going to understand how to interface a reed switch, which is a magnetic switch, and then how to monitor the reed switch status in the DWIN touchscreen LCD display. If you see here in the screen, you are able to see the welcome message which is scrolling, which justifies through DWIN display we can able to create the scrolling display also, which is looking similar to when the car is moving forward and the messages are going backward, something like that. So as we know, this is the touch screen. Every touch is producing some sound. There is a possibility for us to notify the screen is being touched with the help of buzzer. So the entire touch screen is being configured. So wherever you touch, anywhere in the screen, you are able to hear the sound. So when you swipe here, you are able to see the status of the door. In a car, say for example, there are 4 doors. The status of the door can be monitored and it can be notified in the screen, something like this. And this is the place we have to touch to go back to the front screen. And then this is the place we have to go back to the front screen as we see here. So the sensor what we are using here is a reed switch. This is a reed switch which is connected to the node MCU, and this is the permanent magnet which is connected to the door. So whenever the door is coming closer to this reed switch, the reed switch will be on, and then there will be a transition from logic 1 to logic 0 in the GPIO pin that is being notified with the help of switching on an LED in the node MCU, and this node MCU is transmitting the data through UART to the DWIN touchscreen display, and the touchscreen display receives the data and then it displays that the door is closed. So if we are opening the door, so I am opening the door, that means I am moving this magnet away from this reed switch. So there is a transition from 0 to 1, and then the LED is switched off to notify that the door is open here, and then the touch screen shows the door is open. So now the door is closed and now the door is open. Reed switch is closed, door is closed. Reed switch is far away, open. So status of the door, status of the particular positions of any particular door or a window or whatever it is, which can be notified in a car with the help of this touch screen, as we see here. So here, if you look at this block diagram, there is a reed switch which is sending the information to the node MCU. Node MCU is communicating with the touch screen. So node MCU is communicating with the touch screen using serial port where TXD data and this is RXD data, and the reed switch is giving this is 1 bit logical 1 or 0. So here there is a permanent magnet. So this permanent magnet is coming closer, means reed switch will become either 1 or 0. So here reed switch is connected to node MCU logically, logical 1 or logical 0, and the node MCU is communicating with the touchscreen display through UART. So whenever the reed switch is logic 1, it transmits some data. Whenever the reed switch is logic 0, it transmits another data. By receiving that, touchscreen is displaying either open or close to notify the user that the door is open or closed, as we see here. Here in the previous presentation, here we are touching from the touchscreen. Input is given from the touchscreen and you are switching on the LED or the switching on the device. Now the input is coming from the node MCU. Touchscreen is acting as a receiver, and then it receives the data and then it is displaying the received data. That is what we are able to understand here. Here node MCU is communicating with the touchscreen. In this case, where node MCU senses some signal, and then the sensor data is monitored in the DWIN touchscreen LCD display. How this is being done, we can see it in the this is the DWIN DGUS display module, as we see here. So as we see, there is a welcome. It is covered by some rectangular box, which is nothing but which is going to do the animation. As you see here, it is going to do the animation. If I play this, means you are able to see the animation like welcome is moving. and when you do the touch, so you are able to see the open screen as you see here, and this is the one which we have simulated here, and that is the one which is happening in the hardware as you see here. So the hardware, if you swipe here, you are able to get open or close, and if you press this button, it is coming back to the back screen. If you press this button also, it is coming back to the back screen, and if you remove this, it shows open. If you bring closer, it is closed. So the front screen is normal, it is not going to show anything, but if you are going to see the status, means it is displaying open and close as we see here. It's very interesting. The same thing you can able to see here. Here you are able to see the rectangular box here. So this rectangular box is the touch sensitive place, where if you touch here, it will go back to the previous screen. That is what being experienced in these windows. And if you look at the code, Arduino code, if you look at the Arduino code, and whenever you see based on the received data, it is going to display either open or close as you see here. Okay, so that can be animated as you see here. DWIN display has a feature to animate this. So default, this is how it is being animated. This is the virtual screen as you see here, and whenever you swipe, you will get the next screen, and based on the touch, as we see here, if you touch here, it will go back to the previous screen, and all the animations and other things which can able to experiment here with the DWIN DGUS development environment. And this is receiving the data. So your Arduino IDE, this is the Arduino IDE which is receiving the sensor status, and then it is transmitting the values. How it is sensing, we can see the code. Here you are using the header file called software serial.h, where any GPIO can be configured as a serial port. Here we are using D2 and D3 pin to configure, which is configured as a RxD pin and DXD pin, which is a software serial port. And the software serial DWIN serial is configured as a receive pin and transmit pin, where the Arduino is transmitting the data through D3 pin. Arduino is receiving the data from the DWIN display through D2 pin. Those two pins are configured as a serial UART pin for this particular application. And then, as we know, always there is an 8 byte. So those 8 bytes are given here. So every byte is having its own significance. So 5A, A5 and 05, 82, 54, and the remaining last 3 bits are 00. This is the status, default status. And you are using the read switch, you are connecting the read switch to the D4th GPIO pin, and then we are using the LED to notify that whether the read switch is sensing or not. That LED is connected to D5. So the sensor is connected to D4, and the sensor status is monitored in the place, in the place itself is by the help of LED which is connected to D5. And the serial data is of 9600 baud rate, and the DWIN serial data is traveling in a 115200 baud rate, and then we are making the LED pin as an output pin, and then we are using the read switch as an input pull up pin. So because it is pulled up, whenever it is sensing, it is becoming 0. When it becomes 0, it switches on the LED and then transmits 1. That is what the idea here. If you look at the loop, the code is written like that. So if you see the state, initial state, you are reading the digital data, read switch is red first. So default it is 1. When the state is 1 means, default it will go to, if it is 0 means, if the state is low means, it will go inside this loop. Now it is else means default it is 1, because it is not sensing. So if it is 1 means serial print, you are going to print read switch open. So read switch open is getting printed here. Now the switch is open. So you are able to see read switch open is getting printed. To print this in the serial window, you are doing this. That's all. Then because it is open and you are sending 0, you are transmitting 0, that is, you are putting the status byte, that is status of 8th byte as 0. So when the 8th byte is 0 means, and then you are writing the 8th byte, you are writing the 8 bytes continuously to the DWIN display, and then you are writing the logical 0 to the LED pin, so to make the corresponding LED to switch off. So for example, if I am connecting the, if I bringing the reed switch closer to the, if I bringing the magnet closer to the reed switch, the LED is on and then it is displaying close. So this is happening by the state is low. Because the state is low, you are reading the switch pin. The state is low. Because the state is low, read switch closed. Information is getting displayed in the serial window. And then you are sending the serial window status as 1. And then you are writing all the 8 bits continuously in the digital write. You are sending the 8 byte. 8th byte is 1. So when the DWIN display receives 1 means it will display it as closed, and then LED pin is made high. This is how it works. So when the state is low, you are transmitting logic 1 and you are switching on the LED. This is how it works, and where the read switch is sensed and then read switch is monitored in the DWIN LED DWIN touchscreen display. Thank you.